We're going along with bad mic quality, just using the built-in audio for a very short code demonstration here. This is calculating cat years and dog years, and those of you who know me know that I have a fond place in my heart for pets, especially cats and cat girls. So let's continue on with an example of how to do these calculations. We're doing things in JavaScript here. It's very simple. I just need to explain the premises first. So you have a calculation. So yeah, what's the input going to be? The input's going to be human years. And human years are going to be greater than or equal to 1, so there's not going to be 0. I tossed in a stipulation to catch if there was a 0 years old thing, just to put that in there, because that would seem like a use case. A freshly adopted cat that's a new kitten is 0 years old, so that seems like a helpful case to have there. So the way that I structured this is I'm thinking if I wanted to make it maintainable, how would I do the code? But I'm getting ahead of myself by talking about the code, not talking about the premise itself. So when you're calculating cat years or dog years, the input that you have that you're calculating it off of is how many human years old they are. And the output that is desired, the return output, is an array: human years, cat years, dog years. And with this structure, just because cat years is before dog years, I kind of reflect that in my code just to keep things organized. When I'm declaring my variables up here, I declare cat variables before dog variables. And also that makes sense because alphabetical C before D. And I keep that consistent, where cat comes before dog consistently within my function here. So, small things to note. For cat years, the calculation starts off as 15 for year 1, then 9 for year 2, then plus 4 for each year after that. The first two are the same for dog years: 15 for year 1, 9 for year 2, and then plus 5. But then it changes to plus 5 for each one after that. And I will, with that out of the way, I will open up my code to look more specifically at that. And it sucks that I have to resize this to go in here. This is fine. It doesn't really matter. So let's actually look at these. The first year for both cat and dog is 15, but I have this set up as if I wanted to easily change this. Let's say that like a new study came out, and just because of like dog breeding working differently, well, they have a bit of a longer lifetime, so instead of 15, it's like recalculated to 13, where I don't want to go everywhere in here and change 13, 13, 13. I can just change it up here, and then everything else that's referenced later on, I'm referencing that variable, so that's maintainable. Yes, I am using variable references, which I hope it's not confusing, because, I mean, this makes sense. Y1 dog, year 1 dog, Y1 cat, year 1 cat. And even for defining this variable, a 2-year-old dog would be a 1-year-old dog plus whatever the number is for 2. So again, if I had to change this, then I would just have this one place that I'd need to change it. Oh, the calculation is it's only 8 plus 8 years. I could change it here, and the rest of the function would work just fine. So let me explain the rest of this. So I have the variables declared for what the calculations are. I identified, okay, so for human years, how many years is that for year 1 cat, year 2 cat, and then year 3 onward. So I identified the different parts, the different moving parts of this. Year 1 is a special thing, year 2 is a special thing, then we have 3 plus as its own diddly-do to deal with. So I also broke up the conditionals over here of looking at the if-then statements. So we have 2 big if-then statements. So if they're less than 2 years old, then we don't have to do the 3 plus calculation. So if it's just 1, then return the age for year 1 dog, year 1 cat, year 1 dog. If it's 2, then I can reference that for year 2 cat, year 2 dog. If it's 2 human years. And then if it's 0, which I don't know why this would come, I just toss this in here as like filling out a possibility that would be a use case. Yeah, you could have a kitten that was just born that's 0 years old. I just toss this for completion in it. And if I were talking with like a business group kind of thing, I would want to organize this because a return statement, it will exit out of the function once that return is hit. If I'm calculating a whole lot of things, and this depends, the way that this is structured needs to have speed in mind, then I would want the business case that's the most common to come up first. So the way that this is structured, I'm assuming that the business case for the most common would be a 1-year-old cat, and then the second most common would be a 2-year-old cat, and then that'd be kind of rare to have a 0-year-old cat that this function would be used for. So thinking in a business mindset, you want to prioritize the calculations, even though it's like microseconds, yeah, whatever. It does, in order to reach the 000 conditional, the program does have to execute, does have to check, is it 1 year? Is it 2 years? And then it would get to the 3-year, or the third situation, not the 3-year-old cat. That's also why I have this up here, is because we don't have to do any of these calculations. We can separate that out entirely if we're doing this other calculation over here. That's 3+ years. And also, it's a very tiny thing to do a mathematical calculation, but that is more performance heavy, quote unquote. So that's why I have this sectioned off in its own thing. Doing this calculation is more performance heavy than just making a declarative, or just referencing the variables from where I declared them up here with just the if-then conditionals. So I am doing a calculation with how many human years is it, subtract it from 2, and then multiply that by the plus 3 years, and then add that to a 2-year-old cat. So you're starting, if the cat's 2 years old, then it's 24 in cat years. And then for each twilight year, each 3+ year after that, then it multiplies it by whatever the age rate is, times the number of human years that exceeds 2. Another small thing is I do have a couple of variables in here. Or not variables, yeah, I do have variables up here, but what I want to say is I have a few comments up here just to make it more readable and maintainable. So if someone else had to pick up this code, this is a stupid example, yes, but I'm doing this to demonstrate a point, that if someone else had to read this code and understand what's going on here, things are neatly organized so someone else could pick this up. Also, I want to put this in here because the 3+ thing does differ from like a straight declaration of this is used in the calculation on this down here. So that's why I wanted to put this. That is the rate that they're aging, not just at year 1, it's this. At year 2, it's that. Then it becomes standard after 3 onwards. Anyway, I just wanted to point that out about structuring, and I explain what's going on below this. This is the 3+ calculations down here. This up here is less than 2 human years. So I'm explaining what's going on in the key conditionals going on here, and like else doesn't have anything for it. So that's why I want to have this comment up here just above it. It's like, wait, what case is else dealing with here? It's dealing with if the cat or dog. Yeah, so that I'm satisfied with that. And then again, the return is human years, cat years, dog years, as was the request from the instructions. So I just thought this was a good microcosm of kind of explaining an approach to make code maintainable. Because if I were programming a video game or something, and these were like stats for items, where I go, oh, this is too broken. The scaling of this is too broken. It shouldn't be 4. It should be like 3.3 or something like that. Then using this style of referencing helps. Let me just put my line terminators here. I'm not using my integrated development environment for doing these because this is on Code Wars. But I actually have to install Node.js because my command line's not running JavaScript right now. And I go, oh, well, that kind of makes sense because I'd only run Python prior. So I do have to do some more setup stuff before like actually training more complex things. I think this is like my upper limit for complexity that I can manage without messing with my IDE. And this is pretty simplistic, admittedly. But that's why you'd want to be able to like practice things and see what the outcomes are aside from just running like this this fake environment here. So if I test this, then it will pass with the calculations that are there, doing it correctly, getting the expected outcomes that are there. Again, I did want to focus more on like how would you make something maintainable and easy to update, and having all the operative variables, all the keys, things that you want to deal with in one spot right there. That makes it really easy to go back and tweak later on, especially if you're doing some kind of iterative development where you're not sure about these values or they might change in the future. And then everything else down here is just references to it, references to the previous variables. And yeah, it's solid. So thank you for watching that. And I apologize for the poor audio quality, but this is just something like really quick to get off my mind. Thank you for watching.